A pleasant greetings to all. In this video, I am going to explain signal flow graph in control system. What is signal flow graph? Signal flow graph is the graphical representation of algebraic equations. Next, signal flow graph is the simplified version of block diagram reduction technique. What is the use of signal flow graph? The signal flow graph, which is used to find out transfer function of any system. What is transfer function? Transfer function is the ratio of Laplace transformation of the output to the Laplace transformation of input. Before we are going to see the transfer function, first of all, we should know the basic elements of signal flow graph. Nodes and branches are the basic elements of signal flow graph. First of all, what is node? A node is a point which represents either variable or a signal. There are three types of nodes: input node, output node and mixed node. What is input node? Here R is the input node. The input node is the one which has only outgoing branches. And next, output node. Here C is the output node. It is a node which has only incoming branches. And next, mixed node. Node 1, 2, 3, 4, 5 all are known as mixed node because it has both incoming branches and outgoing branches. What is branch? Branch is a line segment which joins any two nodes. Here node R and 1 is joined by a branch. What is the gain of the branch? That is 1. Next, path. It is a traversal of branches from one node to other node in the direction of branch arrows. It should not traverse any node more than once. And next, forward path. The path that exists from input to output, that is known as forward path. Then loop. The path that starts from one node and ends at the same node is known as loop. Here this loop is known as self loop. And here this is the normal loop that starts from the node 3 and ends at the same node 3. And next, what is non-touching loop? The loop with no common node, that is known as non-touching loop. Here this is the self loop and this loop is the normal loop, both not having any common node. So both the loops are known as non-touching loop. Then path gain, product of gains associated with each branch that is encountered in a traversing a path, that is known as path gain. Here, for example, I am going to consider the forward path 1 that starts from R and ends at C. So, what is the gain involved in the forward path? That is 1 into G1 into G2 into G3 into G4 into 1. That is the gain product of the forward path. Next, I am going to explain how to find out the transfer function. Here, the transfer function of any signal flow graph is found out by means of Mason's gain formula. So, what is Mason's gain formula? T is equal to C of S divided by R of S. C of S is the output, R of S is the input. Summation K is equal to 1 to N. Here number of forward path. The forward path that starts from 1 and ends at N. MK. MK is the number of forward path. Kth number of forward path. Delta K divided by delta. how to find out delta? Delta is equal to 1 minus sum of all individual loop gains plus sum of the gain products of all possible two non-touching loops minus sum of gain products of all possible three non-touching loops plus sum of gain product of all possible four non-touching loops and so on. And how to find out delta k? Delta k is same as delta, but the loops that are not touching the kth forward path, that is taken into account. These are about Mason's gain formula. Next, I am going to explain how to find out the transfer function for the signal flow graph. So before finding out the transfer function, first we should know the Mason's gain formula, because Mason's gain formula, which is used to find out the transfer function. So C of S divided by R of S equal to summation K is equal to 1 to N Mk delta K divided by delta. So this is the step number 1. And step number 2, find out the number of forward path. So how to find out the forward path? So to find out the forward path, the path which connects input and output. So that is forward path. Here this is the first forward path. Okay, from input to output. And next, find out the second forward path. Here this is the second forward path. Okay, this is second forward path. Okay, now I am going to write the first forward path and second forward path. So what is the gain in the forward path? 1. 1 into G1 into G2 into G3 into G4 into 1. That is equal to G1, G2, G3, G4. Next here, the gain is missing. So I have to take it as G5. Next, second forward path P2. How to find out this? This is the second forward path. So 1 into G5 into 1. That is equal to G5. Second forward path is over. After finishing this, I am going to find out the individual loops. So the first one is, this is the first loop, starting at the node number 2 and ending at the node number 2. And next, this is the next loop, starting at the node number 4 and ending at the node number 3. And next, this loop, starting at the node number 4 and ending at the node number 4, that is loop number 3. So we are having 3 individual loops, loop 1, loop 2 and loop 3. Now I am going to write the gain product of loop 1, loop 2 and loop 3. Here this is loop 1, and this is loop 2 and this one is loop 3. Okay, I am going to write the loops individually. Loop 1, what is the gain product? Minus H1. And what is loop 2? That is G3 into minus H2. G3 into minus H2. And what is loop number 4? 3. Loop number 3 is equal to G4 into minus H3. So minus G4 H3. So all the loops are over. And next I am going to find out non-touching loop. Here consider the loop number 1. and again consider the loop number 3. So is there any common node between 1 and 3? No. So both are non-touching loops. So how to write this? L13. So L13 equal to minus H1 into minus G4 H3. So these two are non-touching loop. H1, G4 and H3. That is equal to L13. Now all the processes are over. Next I am going to find out what is delta 1 and what is delta 2. Before finding out delta 1 and delta 2, first I should know what is delta. So delta equal to what? 1 minus sum of individual loop gain. So what are the individual loop gain? L1 plus L2 plus L3 plus sum of gain product of two non-touching loop. Is there any other non-touching loops are available? No. There are one pair of non-touching loop is available. So delta equal to 1 minus L1 is minus H1. L1 is minus H1 plus minus G3 H2 again minus G4 H3, then plus what is L13 H1 G4 H3. Now have to combine all. So 1 minus of minus in minus into minus, that is plus 1 plus H1 plus G3 H2 plus G4 H3 plus H1 G4 H3. So this is delta. Okay, now delta is over. Next I am going to find out delta 1. So what is delta 1? Delta 1 is same as the delta, but the loops are not touching the first forward path. So here the forward path is G1, G2, G3, G4. Here all the loops are touching in a forward path. So what about the value here? 1 minus 0. There is no loop that are not touching in kth forward path. Then delta 2. Here this is del 2. Here the loops that are not touching in the forward path is L1 and L2. So 1 minus H1 minus G3 H2. Okay, and what's the answer? 1 plus H1 plus G3 H2, and again the two loops are non-touching loops, sum of gain product of non-touching loop. So H1 G3 into H2. Now this is over. This is delta 2. Here only one mistake in delta. Here both are non-touching loop. In the similar manner, L1 and L3 non-touching, L1 and L2 also non-touching loop. So I have to take into account L1, 2. So plus H1, G3 and H2. This is delta. Okay, now I am going to find out the final transfer function. T is equal to what? First write P1 delta 1. So what is P1? Here P1 or M1, M2. So M1 is what? G1, G2, G3, G4. What is delta 1? Is 1. And next plus G5 into what is delta 2? 1 plus H1 plus G3 H2 plus H1 G3 H2. Numerator is over. What about the denominator? Write the delta value. So this is the transfer function of the given system. Thank you. Have a nice day.